Good afternoon, everyone. I'm finally home in Newfoundland, just making a quick video on bypassing stack cookies. We're going to be using the same concepts. We're going to bypass DEP as well. The only difference, we will be using the PETA plugin to find a few different things instead of just our normal GDB. So just let me get into our Linux where we live. Let's open up our terminal. Let me get to my working files here. Actually, sorry, day 3 stuff. This is part of the program I'm doing up for my Ukrainian friends. CD day 3. And I have a program made up here, vulnprotected, and I'll just show you what it looks like. I just have a little scanf put in here to stop at the A at the beginning, and you can put this into any program you want. It's compiled with no protections, so stack protection is off, and so is DEP. DEP is turned on, and so is stack protector is turned on as well. So just a straight up program, bypass 2 of them. Okay, so let the fun begin here. Let's open up our GDB/Q vuln protect it, and I'm just going to open it up in normal GDB because I don't really like the PETA plugin, but it allows us to get the addresses at the libc library. But as much as I can, I just like normal GDB. Call me old-fashioned. Okay, so looking right up to start, we have a stack size of 20 hex. So just print 0x20. And that's 32. So this gives me what display size I should use. So I'm going to display, give me 36 words a hex from the ESP. I'm also going to display 2 instructions of EIP, so I see where the program's going next. Right here is the actual stack cookie. You see this GS0x14. being pushed in EAX. This is the stack cookie being pushed into the EAX, and then the EAX is pushing it to 0x1c of ESP. So once we get inside the program, we can count. So let's just do 0x1c, and as you can see, that's 28 from the stack pointer. I'll show you a quicker way of doing it, but you can just count from the stack pointer down the stack, and you can see the stack cookie we're going to be replacing. Down here towards the bottom, it moves that same 0x1c position, 28 from the stack pointer. It moves it into the EDX register. Then it does an XOR operation, which is compares the stack cookie before and then the stack cookie now. Now, if we overwritten that stack cookie with something else, like we did in the simple buffer overflows, it's going to detect that we are doing stack smashing, and it's going to jump equal, which is the next call, and it's going to jump to call stack check fail. So that would be the stack cookie working. What we're going to do, we're going to stop it midstream. We're going to put in all our same DEP bypasses we did before. We can't put our shell code onto the stack because DEP is enabled. So we need to find things in the libc library that we can use instead of our shellcode. So we can find system, we can find exit, we can find binsh in the libc library. So what we will do, we're going to run this program, and I'm going to run it with Python because I'm a badass. And we're going to print, let's do A times 24. I think that should crash it. Let's see here. A times 24. That's better. So now what we're going to do, we're going to run the program. We're going to put an input of 24 A's into it, and I'm thinking that's perfect for overwriting the EBP, and then we'll crash the program. And I'll just let you see how the stack cookie works. Let's copy. Before I do that, let's put a breakpoint in here. Breakpoint just at the stir copy, which is the vulnerable function that doesn't do bounds checking, right here. And then let's we will run $ Python /c print a times 24, and let's start running the program. So here we go. And now let's look for that stack cookie before we copy all our A's in. So I'm going to examine words in hex. 0x1c, so that's 28, plus the EBP. So here you go. So it's at 0c4. So here's C, and it's 1. Hold on now, that is wrong. This right here is the stack cookie. What did I mess up there? What did I mess up? 0x1c. So let's do, is it minus? It must be minus. Oh, for the base pointer, I'm an idiot. 0x1c plus ESP from the stack pointer, please. Now that makes sense. Now we're at 9c, which is right here, and you can see this here is our stack cookie. Sorry about that. That's messing around in assembly and the memory. As you can see, every stack cookie has a 0, 0. You'll notice right away. So it makes it really easy to pick up little mistakes like I just made then. So now we will hit next instruction, and of course all our A's get written in here, and as you can see now the stack cookie is overwritten with our variables. So what's going to happen? Stack smashing is going to get detected and the program is going to crash. As you can see, stack smashing detected and our exploit's not going to work. So now what we need to do, we need to craft up a new exploit here. So let's go back to Python. So 24A's worked good. That overwrote our EBP. Here's our return function right here. This is our argument count right here and our argument vector right here. So we need to overwrite this one with our system call from the libc library. We need to overwrite the count with the exit function from our libc library. And again, from the libc library, this is where our binsh is. This is where we're going to get our shell, because we can't put shell code on the stack or anywhere in memory that it's not supposed to be, because we have data execution prevention turned on. Little sip of bubbly here. Okay, so we know that is the basic layout of our exploit. So what I'll do now, I'll just put each of these, of course, is a word, 4 bytes. So I will put in 4 bytes just to make sure everything's lined up and copacetic. And then we will get into exploiting this. Let's restart it. Okay, so we are right back to the beginning. So if we do XWX ESP, not EBP, plus 0x1c, then you can see at 9c, which is right here, we have this 600. And again, you can see 0, 0 at the end, denoting a stack cookie. So now that we have that figured out, why don't we copy this? Now, the last time we did this, it came out with stack smashing. So I'll show you how to get past the stack smashing right now. What we'll do, we'll hit next instruction. We'll bring in our inputs, and then I will change the stack cookie mid-flow here in our program. So as you can see, the stack cookie is overwritten with 414141. What happened last time? It detected stack smashing and it crashed the program. So what we will be looking for is just a segmentation fault this time. And if we get our segmentation fault, then I'm going to switch over to my PETA plugin, and we're going to find our system, our exit, and our binsh, and we're going to take over the system and get shell. Okay, so now that we have done that, I'm going to set int. Now I'm going to bring over my cookie address as soon as I find my let's bring over my cookie address right here. And of course, I need to put an equals. So this is saying this piece of memory, which is over right here, should be this here. So we're overwriting the memory ourselves. Everything works fine. Let's just hit next instruction here. And as you can see, our 4 ones have continued on here. Our stack cookie got replaced here. So when it checks it at the end of the program, it's going to say everything's copacetic, everything's fine. The rest of our 4 ones fill up the stack. 4.2, which is our B's, is going to be our system address. 4.3, which overwrote the argument count, is right there. And that's going to be replaced with exit. And then our 4.4 is overwriting where our bin sh is going to go. Each of them 4 bytes, 1 word. So if we can just continue this program, you're going to see segmentation fault. This is really good. That means we just bypassed the stack cookie. Very cool. So I'm going to quit out of our normal GDB. Yes. And what we're going to do next is we're going to start crafting up our exploit. So I'm going to change over to my root account where I have my GDB plugin, PETA plugin, vuln protected. Okay, so we have vuln protected here. Let's disassemble the main function. And all I'm going to do this trip around, guys, is grab our system, exit, and bin sh. So I'm just going to put one simple breakpoint here. You need to be doing it during runtime to find the addresses in the libc library. So I'm just going to run. And what I'll do now, I'm going to print system. As you can see here, here's our system address. So this is going to be replacing our B's. And let's paste this in here just to keep notes. System. Now we're going to look for our exit function in the libc library, which is right here. Let's copy that out. This is fun stuff. So fun. Paste, exit, and finally our bin sh. We had to use the find command. And there's our bin sh. There's so little entropy on these, you can almost start guessing where they are. I swear to God. And we'll write that bin sh, close enough. Okay, so now we have all the information we need, except for that old cookie address, which we'll try not to get confused on. Now we can start crafting our exploit. We can just continue on with this one. And let's quit out of our GDB here for now. And we'll open a new, open a new terminal. And we'll get to our working files. Day 3. Now we're going to start working our exploit. So what I'm going to do, I'm going to run the program, put it in the background, and then we're going to attach it into our GDB with PETA plugin. What we will do is overwrite this program will be running. We will attach into the program. We will overwrite the stack cookie, and the rest of this stuff will go in and bypass the DEP. So we bypass 2 protections all at once. So this will be fun. So vuln protect it, and then we're going to run that with some Python. Print. So we have our A's times 24. We have our 2, 3, 4 bytes of system. So we can put that in right now. We're looking right at our system. So little Indian convention, we put it in backwards. So it's 10, 33, E5, and B7. Entropy so load are all B7, which is kind of cool once you start getting into it. So let's put in 4 more X's. And we're going to put in our exit function. This is overwriting the argument count. So it's 60, 62, E4, B7. Perfection. And our last one, our shell, the all-important shell. We're going to put in 4C, 5D, F7, see how easy it is to mess up, and B7. So perfection, let's put our, don't forget our little tick here. I'm going to put it in the background with the and sign here at the end, and that looks good to me. Here we go. So I'm just going to foreground 1. Now I'm going to take this address here and we're going to attach it into our GDB. So let's go back over to our GDB. And we'll open up GDB/Q without anything. I'm going to attach, and we'll just use that process ID that we just copied. Okay, so disassemble the main function here. Now the first things first, I'm going to put in a breakpoint at the stir copy here, or just before the stir copy. Give myself a couple extra instructions to play with here. So I'm going to put a breakpoint here. Now we're just going to go inside. Now all of the system functions and everything's already running in this program as inputs. So what we're going to do is set our breakpoint there, and we'll just hit continue, continuing. We'll come over here, just drop an input. Now, I'm going to display 36 words from ESP. Okay, so let's examine. I can already see my stack cookie, but doing it this way gives us the address and everything instead of having to copy it in 2 places. So this is the easiest way. You could count back 28 like I showed you. So just copy there. And everything's looking good. So I'll come over here just in case I mess something up here. Now, let's hit next instruction. Okay. So now next instruction should bring our inputs in. And as you can see, there's our system address. There's our exit. There's our bin sh. Everything looks fine, but right now, if we were to continue, this stack cookie isn't set right here. It's covered with 414141. Now we could edit this just in runtime. I'm just thinking about it now. Like we could edit this in just in our inputs alone, right? If we do some counting, some arithmetic, but an easier way to do it, we can just set this integer int, and I just need to put a equals in between these here. Let's take, oops, let's go over here and get the symbol right. Excuse me. So here we go. So now we can set this. Let's hit our next instruction. And as you can see, 4141, our stack cookie is in. This is all looking good. So what I'm going to do now is detach the program. Detaching from program, and when we come over here, boom, we have shell. And that, my friends, is how you bypass data execution prevention and stack cookie protection. Stack cookie protection was actually developed by one of my friends, Chris McCallum, or him and his team, in 1996. So it's kind of fun. Just this is why I love Twitter. The access you have to people on this platform is just like it's amazing, absolutely amazing. I hope you enjoyed this. This is just some basic concepts I'm passing on. And if you have any questions, hit me up in the comments or send me a DM. I'm always happy to talk about hacking, especially exploit development. I love you guys, and I shall chat to you guys in the next video, which is going to be going over Relo exploits. Super fun. Chat to you later. Bye.